Hello my dear students, this is Dr. 𝗲𝗵𝗺𝗺, your biochemistry faculty. Well, in this video, we are going to discuss about a very interesting topic and a very prevalent topic or a common one nowadays which is very prevalent, alcohol metabolism. You know, alcohol has become, rather it was earlier also, a most wanted drink just to come out from depression, just to, get a source of happiness like that. But have you ever wondered that whenever we are consuming alcohol, how it is being metabolized in the body? This is very important. And so many things are there because whenever we are eating something, just if we are eating carbohydrates, what effect these carbohydrates produce on our body? If we are having proteins, if we are having fats. Same is the case with alcohol. We know that excess of alcohol is harmful. Nowadays, so many rehab centers are there because if a person is addicted to alcohol, it can lead to so many things. And in fact, most of the family disputes are because of this alcohol intake. So, how this alcohol is metabolized in the body? In what form it is available in the body? Because there are so many drinks which are there. If we talk about wine, if we talk about beer, if we talk about anything. So, indirectly or directly, we are consuming alcohol. So, the thing is that to what excess it can be used? Yeah, if it is causing damage, so what are the basic biochemical parameters by which we can assess the damage to the organs? So, that is all what we are going to discuss in today's video. So, and it's just a biochemical reaction which is taking place in the body. And whenever we talk about any kind of metabolism, always keep one thing in mind. It is the liver which is the one which is most affected. Why? Because liver being the kitchen of the body. Okay. So, now coming over to this, what are the different type of alcohols first of all? So, if we talk about the alcohols, type of alcohols, ethanol or ethyl alcohol, methanol and isopropyl alcohol. If we talk about ethanol, it is least toxic. And if we talk about isopropyl alcohol, it is most toxic. Right? So, always remember ethyl alcohol or isopropyl alcohol. Isopropyl alcohol is the most toxic one. Then whenever we talk about the metabolism, always remember, just now I told you the site is always the liver. So, site is liver. Right. And if we talk about the pathways, how it is catabolized. So, pathways include the major pathway, will include cytoplasm and the mitochondria, and the minor pathways will include the peroxisomes, and MEOS, which stands for microsomal ethanol oxidizing substance, which is a part of endoplasmic reticulum. Substance, or you can say system. Right. Now, whenever we talk about where maximum absorption of alcohol takes place, that is also very important. So, whenever we talk about the absorption, always remember 80% of alcohol is absorbed in the intestines first of all. 80% absorption takes place in the intestines and 20% takes place in the stomach. Right. Now the question is, first of all, we will discuss how this alcohol is metabolized. So if we talk about, say, ethanol. Okay, ethanol will be first of all converted into acetaldehyde, and this acetaldehyde will be converted into acetic acid. Okay. Now, if we talk about methanol or methyl alcohol, methanol will be forming formaldehyde, which forms formic acid. Right? Because if we talk about whether it is ethanol, whether it is methanol, it is an alcoholic group. And we know that this alcohol on oxidation will form an aldehyde, and this aldehyde on oxidation will form a acid. Right? You can say oxidation, or the enzyme is dehydrogenase or dehydrogenase. Okay. So this is how the conversion takes place, and whenever we talk about dehydrogenase, always remember the enzyme here is alcohol dehydrogenase, or we can call it as ADH. Very important enzyme, and it always requires NAD or NADH. Now, if we talk about the metabolism here, so what is happening? Say this is the cytoplasm, say this is the mitochondria. So what happens here is, in the cytoplasm, ethanol forms acetaldehyde. Okay, the enzyme is aldehyde, this alcohol dehydrogenase, and NAD is converted into NADH. Okay, so this acetaldehyde will enter in the mitochondria and it will be converted into acetic acid. Again, NAD will be converted into NADH. Okay, so I can say this is the cytoplasm and this is the mitochondria. Now this is the major pathway of alcohol consumption. Now there is the minor pathways. So the minor pathways, if we talk about the peroxisomes, what is happening in the peroxisomes and what is happening in the endoplasmic reticulum. So what happens is, in the peroxisomes, whenever we talk about peroxisomes, only one thing comes to our mind, and that is H2O2. So what happens is, it is coupled to H2O2. Okay, which is linked to again this that we will discuss now. And if we talk about this endoplasmic reticulum, here microsomal ethanol oxidizing system is there. So this MEOS is basically accelerated or activated by this CYP2E1 protein, and here it is linked with NADPH. Now you have to just understand one difference, that there is a difference between NADH and NADPH. Okay, and this is microsomal ethanol oxidizing system. Right. Now what is happening is, we can say that this ethanol is producing acetaldehyde, and this acetaldehyde is being transported in the mitochondria, where it is again immediately undergo dehydrogenation, forming acetic acid. So what happens here is, whenever we have high intoxication of alcohol, so whenever there is accumulation of acetaldehyde, it leads to nausea, it leads to vomiting, and it leads to a kind of flushing syndrome, and that is what, it is a common observation in majority of the people, ki whenever there is excess of alcohol, whenever intake of alcohol becomes more, the person feels highly nauseated. Why? Because of accumulation of this acetaldehyde, and immediately it is converted into acetic acid. So what happens is that increased accumulation of acetaldehyde will lead to nausea. These are the common features. Vomitings and a kind of flushing syndrome. Sometimes the person will become, totally red because of the increased production of dopamine, and then his pupil will be dilated, and later stages he might slip into coma where the pupil will be then constricted. So this is like a stepwise behavior when a person is taking alcohol. So this is also known as, and it is like genetically inherited also, so it's like a genetic variation. And in Asians it is seen, so it is also known as, since it is seen in Asians, so it is known as Asian flush syndrome. Very important. Okay. So now see what happens here is that what are the I would say consequences of alcohol intoxication. So consequences are there are basically three consequences. If we talk about the first one is simple, a kind of euphoria is there. Euphoria or a kind of excitement is there. And why this excitement is there? Because of dopamine secretion. So it's like initially the person can be happy also. Second is there is lack of coordination. So it is incoordination, or you can say lack of coordination is there. There will be a change in the walk also. So lack of coordination, why it is there? Because the pupils are dilated. So it is difficult for a person to see also properly. Right? So I can say change in the walking style, change in gait is also there, is observed. Right? And third is later stages mein it leads to coma. And when coma condition kind of condition occurs, it is like the pupil is constricted. Now, coming over to this, these are the consequences of alcohol intake. Now, if we talk about this, you can see that ethanol is being oxidized to acetaldehyde, and this acetaldehyde, when the concentration is increasing, this is a very fast reaction I told you, and immediately this acetaldehyde will be converted into acetic acid in the presence of alcohol dehydrogenase. Now, sometimes what happens is that if the concentration, if alcohol intoxication is more, so what will happen is this NADPH thing will be accelerated. Why? Because the Km here is high. So if the Km is high, automatically the affinity with the substrate is low. But here I am telling you, when the substrate becomes more, it becomes a clearing factor. I'll just repeat it. What is happening is the major pathway, if we talk about the alcohol consumption, is your cytoplasm and it is acetaldehyde. But what is happening here is, see, this is say cytoplasm and this is say the mitochondria. So here, and this is say your endoplasmic reticulum. So here this ethyl alcohol C2H5OH is forming acetaldehyde CH3CHO, and it is forming NADH. Okay, and this CH3CHO is being converted into CH3COOH again by forming NADH. Okay, this is occurring in the cytoplasm and this is occurring in the mitochondria. And this is the endoplasmic reticulum. Now what is happening is when the alcohol consumption is in excess or alcohol intake increases. Here 𝗲𝗵𝗵 is there, 𝗲𝗵2 is there, and it is basically acting only when alcohol consumption increases. Why? Because here the enzyme which is working, the system is MEOS. Here the enzyme has high Km. So if the enzyme has high Km, it has low affinity with the substrate, that we know. This Km is inversely proportional to the affinity of the enzyme with the substrate. So when the enzyme has high Km, low affinity with the substrate, but here if the alcohol consumption increases so much, because the person is totally intoxicated with alcohol, this MEOS system will be generated automatically. So when this MEOS system is generated, NADPH will be produced. So if the alcohol intake is okay, I mean like it is protecting also, but yes, excessive alcohol intake will increase the accumulation of NADPH, which will start fiddling with our free radical mechanism, which is also known as ROS, which is going to disturb DNA, which is going to disturb proteins. So you can just see that increased concentration of alcohol or addiction of alcohol can lead to so many problems in the body. Initially nothing will happen, because if you see this, NADH is being produced, not NADPH. Okay, and NADH automatically it is being reused again and again, so the normal process is going on. But what is happening here? Increased consumption of alcohol, consumption activates MEOS system. And MEOS system, when it is activated, so I can say that the enzyme has high Km, so it leads to more and more production of this NADPH. So in normal alcoholics, it is protective in function. But in chronic alcoholics, it leads to, in chronic alcoholics, it hinders or it interferes is the correct word, it interferes with ROS. ROS is reactive oxygen species. Reactive oxygen species. Or whenever we talk about ROS, it is going to destroy or disturb the free radical mechanism. It is going to disturb the free radical mechanism. Very important. Okay, so actually what happens is ki increased alcohol consumption increase this, and increased activity of CYP2E1 will be accelerated, leading to more production of NADPH, leading to again you can say excessive this. So this is also very important. On the other hand, I told you ki here peroxisomes are also playing a major role. So it is going to interfere with H2O2 also, like this. Now, what are the biochemical manifestations? Because here we are dealing with alcohol metabolism. So what happens if we talk about this? So what is the effect of this? So the most important, I would say, or the effect of alcohol consumptions are consumption. Now see how it is interrelated. I can say that ethanol is being converted into acetaldehyde. Okay, so it is going to increase NADH. On the other hand, the other reaction, if we see, acetaldehyde is being converted into acetic acid. So here this NAD will again be converted into NADH. If I say increased intake of ethyl alcohol will increase NADH, obviously. So there will be increased NADH to NAD ratio, plain and simple. And here I will just write the name of the enzyme, alcohol dehydrogenase. Alcohol dehydrogenase, right? Now see, when there is a increased NADH to NAD ratio. सबसे important, if we talk about this, I'll just take you to the first reaction in which pyruvic acid, pyruvate, has two fates. If you remember, pyruvate by a irreversible reaction in the presence of PDH is converted into acetyl coenzyme A, which is oxidative decarboxylation or pyruvate dehydrogenase, or B1 is required here. And this is a reversible reaction in which pyruvic acid is converted into lactate. And if we talk about this reaction, here NADH is being converted into NAD positive. Okay. So if we talk about this, and one more reaction is there, this is first reaction. Second reaction is this pyruvate, or you can say if we talk about oxaloacetate. This oxaloacetate will be converted into malate. Why? Because there is increased production of NADH to NAD. Because if you remember, go back to citric acid cycle where malate, when it was produced, it was converted into oxaloacetate, their NAD was converted into NADH, isn't it? So when in the body the ratio of NADH to NAD is high, that means that more production of lactate will be there, or lactate production will increase. On the other hand, oxaloacetic acid will be converted into malate. So oxaloacetate concentration will decrease. I'll just repeat it again. This is very, very important. What I am trying to tell here is that alcohol metabolism is leading to increased concentration of NADH. Okay, because we have generally seen whenever a person is so much into alcohol, he will immediately undergo hypoglycemia and acidity will be there. So hypoglycemia and lactic acidosis are the two main very, very important biochemical manifestations of alcohol intake. So what factors leads to hypoglycemia? Because the brain also stops working, isn't it? So what happens in how this hypoglycemia is there, or you can say how lactic acidosis is there. So this is the biochemical mechanism rationale behind that. The pyruvic acid, because this is a very important reaction which takes place in the brain. conversion of pyruvic acid to acetyl coenzyme A. Pyruvate dehydrogenase is there, or you can say NAD, NADH plus H positive. But here why we are not writing NADH plus H positive? Because they are all linked. Because pyruvate dehydrogenase is the complex which is involved here. Now, B1 ka aspect we will take later. B1 is TPP. Here I am just concentrating on one thing. What I am trying to tell you here is alcoholism leads to increased ratio of NADH to NAD. When NADH ka concentration increases, pyruvic acid will be converted into lactate. On the other hand, oxaloacetic acid will be converted into malate. So the first implication, or I would say the biochemical manifestations of alcohol intake, the first one is hypoglycemia. Now, why hypoglycemia is there? Because if we talk about oxaloacetate, we all know that this pyruvic acid forms acetyl coenzyme A, which combines with oxaloacetate to form citrate, right? And this oxaloacetic acid is coming from malate, like this. This is nothing but our TCA cycle, right? When there is increased concentration of NADH plus H positive, this oxaloacetic acid will decrease and it will be converted back to malate. That means oxaloacetic acid concentration decreases. And if oxaloacetic acid concentration decreases, or decreased concentration of oxaloacetate leads to depletion of TCA cycle. Why TCA cycle will deplete? Because this is the first substrate, isn't it? So, oxaloacetate being the substrate of TCA cycle, TCA cycle will be inhibited. So, aerobic respiration fails, isn't it? So, no TCA, decreased TCA will lead to decreased ATP. So, obviously, and when oxaloacetate is decreasing, gluconeogenesis also cannot take place. So, you can say here also we can show that decreased concentration of this, no gluconeogenesis. In general, I am saying. So, I can say glucose will also not be produced. So, what is the target of the body? That means the body will undergo hypoglycemia. So, glucose concentration falls, leading to hypoglycemia. Very important. On the other hand, if we talk about the second manifestation, first is hypoglycemia. What will be the second manifestation? Second would be lactic acidosis. Now, again, what is the reason behind lactic acidosis? Because increased concentration of NADH will divert pyruvate to lactate. So, the concentration of lactate will increase. And that is why, just because of this reason, whenever a person is very much into alcohol, it will always lead to nausea kind of thing. Vomiting will be there because of lactic acidosis. Right? And the third one is hyperuricemia. Because this metabolism, this interferes with the absorption or with the transportation of uric acid. Alcohol metabolism interferes with the transport of uric acid. And that is why we say, if a person is very much into alcohol and on the other hand, if there is, along with alcohol, if he is having some kind of meat is there, or you can say seafood is there, whatever mutton and all he is having, so he is more prone. And you will see, like if he comes with an injury, so the metatarsophyllangeal joint will be the one, there will be a swelling in that large toe, which is known as big toe also. So there will be swelling of big toe. That is why generally we recommend that whenever we are having alcohol, we should prefer salads instead of this non-veg food. Right? So this is one of the reasons. So we can say that alcohol metabolism interferes with the metabolism of uric acid. So hyperuricemia, hypoglycemia and lactic acidosis, these are the three biochemical manifestations of alcohol consumption. Okay. Now, coming over to this, I can simply say that, I'll just highlight this. So I can say that it will lead to, first of all, hypoglycemia. Second is, it will lead to lactic acidosis. And third is, it will lead to hyperuricemia. Now the question is that if a person is B1 deficient, okay, so what repercussions that B1 deficient person has, because if he is into intake of alcohol. Okay. So now we are going to discuss, just now we have discussed that what are the biochemical manifestations. You have to just understand it like this, that what is the metabolism of alcohol, how alcohol is being metabolized. I told you that alcohol, with the help of alcohol dehydrogenase, ADH is the main enzyme responsible for that. So this ADH is forming acetaldehyde, which is converting into acetic acid. And acetic acid or formic acid, we say formic acid is again very harmful. That is why we say that methyl alcohol is also a toxic one than ethyl alcohol. And if you remember, we have discussed about this point in competitive inhibition also, about alcohol dehydrogenase, or about if a person has taken more of methyl alcohol, immediately ethyl alcohol is given so that it can just neutralize the effect. Okay, it cannot finish the effect, but yes, it will try to subside the effect. Right. So now this is how the alcohol is metabolized. Now what are the biochemical manifestations? Simple, because alcohol metabolism will always lead to increased concentration of NADH. So when the concentration of NADH increases, everything, the table is reversed. Why? Because NADH ka concentration will immediately convert pyruvic acid to lactic acid. So there will be deposition of lactic acid. On the other hand, increased production of NADH, simple oxaloacetic acid will be converted back to malic acid. So what happens is TCA cycle will suffer, and always remember, that is why we say that whenever there is intoxication of alcohol, the person undergoes hypoglycemia, because oxaloacetate, which is the substrate for TCA, is not available. So aerobic respiration is missing from that person. That is why the brain, there is a lack of coordination. And there is a change in the movement also. Now this is the alcohol metabolism is a normal person. Now the question is, if a person is a deficient of B1 and he is into alcohol, so what will be the repercussions there? Okay. So now my question is, if a person is alcoholic, right, and is B1 deficient, what happens? This is a very, very important concept. Alcoholic and is B1 deficient. Now we all know that B1 deficient means TPP deficient. That means, what is this TPP? It is simply working as a coenzyme, that also we know. Okay. So if we talk about the most important reaction which is occurring in the body, that is this pyruvate. is being converted into acetyl coenzyme A. Now, the most important point to remember here is it is a irreversible reaction. Very important. Okay. And what happens here is the name of the enzyme is PDH, which stands for pyruvate dehydrogenase complex. Right, so we can say that PDH converts pyruvic acid to acetyl coenzyme A, which is an irreversible reaction. And here TPP or B1 is the most important coenzyme. Most important. Now, why it is the most important coenzyme? Because it is taking this carbon dioxide out. Because pyruvic acid has 3 carbon atoms. Acetyl coenzyme A has 2 carbon atoms. So, basically 1 carbon dioxide is given out. And this carbon dioxide is taken over by this TPP. So, TPP is required for oxidative decarboxylation. Oxidative decarboxylation. And we all know that this is a link reaction. It is a link reaction. Okay, so if we say that this TPP is deficient, that means this reaction will not occur. In the deficiency of TPP or vitamin B1, this reaction will not occur. That means the concentration of acetyl coenzyme A will decrease from here. Okay, or the concentration of pyruvic acid will increase. And when the concentration of pyruvic acid increases, this pyruvic acid is diverted to form lactic acid. So, the concentration of lactate increases. So, you can see that alcohol metabolism is related to lactic acidosis in 2 ways. One is directly also lactic acidosis will be there, and indirectly why lactic acidosis is there? Because TPP is deficient. Okay, I would say lactic acidosis will be there due to TPP deficiency. That means pyruvic acid will not be converted into this, or this reaction will suffer. On the other hand, this reaction will be favored. Lactate. Okay. Now the question is, from here acetyl coenzyme A is not being produced, right? On the other hand, the body requires energy. So what will happen? The different other processes in the body will be accelerated, which will give rise to acetyl coenzyme A. But this reaction will not be there. So obviously I can say TCA cycle will also suffer. Now the question is that whenever a person is alcoholic and B1 deficient, it leads to, no doubt we know that B1 deficiency leads to beriberi. Here it leads to Wernicke-Korsakoff syndrome. So if we talk about the biochemical manifestations here, biochemical manifestations, the most important one here is it leads to Wernicke's encephalopathy, right? And Wernicke's encephalopathy mein you just have to remember a mnemonic which is GOA, G-O-A, where G stands for global confusion, O stands for ophthalmoplegia, and A stands for ataxia. A kind of waddling gait will be there. Okay. So sometimes scissoring gait is there, that depends. So Wernicke's encephalopathy में global confusion because he is already into, because the brain stops working. Why brain is not working? Because of depletion of TCA cycle. Because always keep one thing in mind, TCA cycle को वैसे भी we call it as a amphibolic pathway. Why? Because it is the crux of all the processes, whether we are having carbohydrate in our diet, whether we are having fat in the diet, whether we are having proteins in our diet, all will undergo TCA cycle, which is linked to electron transport chain, which is linked to oxidative phosphorylation. So everything is interrelated. Okay. So this Wernicke's encephalopathy will lead to global confusion, ophthalmoplegia and ataxia. There will be nystagmus, there will be change in the rotation of the eyeballs. And obviously, if the person cannot see properly, lack of coordination is there. Okay, so lack of coordination will also be there, but you just have to remember Goa. Goa is the main feature. Lack of coordination. Right. And then if it is not treated, it will lead to 𝗲𝗵 psychosis. 𝗲𝗵 psychosis. And if we talk about the major symptoms of 𝗲𝗵 psychosis, here amnesia will be there. There will be a kind of loss of memory. Because either he is going to, that varies from person to person, either he is going to remember only the good memories or he is going to remember only the bad memories. So it can lead to amnesia, whether it is anterograde or whether it is retrograde. And this amnesia will later on lead to confabulations. Confabulation means he will have a habit of cooking stories. Cooking unnecessarily stories. Like, he will be dreaming, just like, it's like Mungeri Lal ke Haseen Sapne kinds. Because he will be dreaming as if he is, going somewhere. He is having his best of the time. So again, if he is into bad memories, he will have the worst. If he is having good memories, he will think he is flying high. So overall, we call it as Wernicke's 𝗲𝗵 syndrome. And why this is so? Because of the deficiency of B1. Why? Because B1 plays a very, very important role in this. In alcohol metabolism also. Okay. And what happens is, if a mother is very much into alcohol intoxication, that is also very, very harmful. That is why during the entire pregnancy period, the mother is strictly instructed not to have alcohol. Why? Because again, this is the one which is going to cross the placental barrier. So if the mother is alcoholic, and mother can be B1 deficient, any of the cases. So if the mother is alcoholic, it is going to again affect the child. Now how it is going to affect the child? It is going to affect the child or the fetus, I would say. Fetus is the correct word. And it will lead to, how it is going to affect the child? Because it will lead to, basically, the child will be having very kind of, I would say, very weak during birth, weak at the time of birth, right, low IQ he will have. It might sometimes lead to developmental delay also. Okay, so these are some of the things. That is why mother is strictly advised not to have alcohol during pregnancy. And if mother is alcoholic, this is another thing. And if mother is having, this is also known as fetal alcohol syndrome. This one, it leads to fetal alcoholic syndrome. And if a mother is alcoholic and B1 deficient also, that is altogether a different thing. Mother is alcoholic and B1 deficient. It will lead to infantile beriberi. Beriberi. So this is also very important. Okay. So this is about alcohol metabolism. Then after this, then we come over to another very important feature here, that what are the markers of alcoholism? What are the biochemical markers? Now, if we talk about the biochemical markers, the most important one here is, just we talk about ALT, because liver is the one which is damaged, because I told you the site of alcohol metabolism is liver. So, if we talk about the alcoholic markers, if it is related to alcohol, it has to be AST. AST or SGOT in alcohol. Alcoholic fatty liver diseases. Diseases. It will always show a rise because the liver is damaged. Second, we can say gamma GT, which stands for gamma glutamyl transpeptidase. So we can say these two are the very important markers of alcoholism. Sometimes it is written as GGT, so it is one and the same thing, gamma GT or GGT. It is gamma glutamyl transpeptidase, and to make this parameter normal, a person should be abstained from alcohol for approximately 2 weeks. Okay, so this enzyme can come normal, if there is abstinence from alcohol for at least 2 weeks. Okay. So, AST and GGT, these are the ones, and then we can say lipase or amylase. These are, again, this is also a marker because alcoholism might lead to acute pancreatitis also. Acute, this is the last resort because liver is also malfunctioning. Pancreas will also slowly stop functioning, because again, if we talk about the biochemistry behind this, there are so many reasons which can lead to this, but we are not going into that much detail. So just remember one thing, these are the main marker enzymes for alcohol metabolism. And then when we talk about the treatment. So if we talk about the treatment of alcoholism, main is the person should be sent to, first of all, rehab centers. Complete abstinence from alcohol is the only remedy, and disulfiram is given. So this disulfiram, when it is given, so what it will initially do, it will basically increase the concentration of acetaldehyde. Initially, if we talk about the functioning of this, so it will increase the concentration of acetaldehyde. Okay, so the person might think ki maybe, so, and I told you ki whenever there is increased concentration of acetaldehyde, it leads to nausea, it leads to increase in vomitings, right? So he might be, a kind of stress will come ki let's take alcohol just to avoid this. But yes, the willpower is very, very important in a person who is taking so much of alcohol. So I would say rehab centers mein disulfiram is given, and you can say which is increasing acetaldehyde, which will increase. So he might be scared also. And third one is complete abstinence, complete withdrawal or complete abstinence from alcohol. is required, and which requires mainly the willpower, which again varies from person to person. So this is just a treatment. Okay. So this is what is alcohol metabolism, which is very, very important, because alcohol plays a very important role and a significant role also in the body. And always remember the maximum absorption, because alcohol is responsible for the formation of fatty liver also. If I talk about fatty liver, so this alcoholism will always lead to fatty liver. And if we talk about fatty liver, what is the factor which is increasing here? During fatty liver, endogenous TGs are the ones which will increase the most. So endogenous TGs here will increase. So the entire metabolism will be hampered. We know that endogenous TGs ke liye what is involved? VLDL is involved. So VLDL will be there, and again if VLDL is there, LDL will be there. There will be increased concentration of cholesterol, because if we talk, so we can say that VLDL will increase. It might lead to increase in LDL. It might lead to increase in cholesterol, or it might lead to increase in CADs or CVDs also. Okay. So this is the entire metabolism of alcohol, and what you have to just focus on this thing, you have to focus on this enzyme alcohol dehydrogenase, okay, ADH enzyme. So if I have to just summarize this, or you can say if I summarize this alcohol, so I can say that alcohol consumption, right? Simplest language में it always increases NADH to NAD ratio. And whenever there is increased NADH to NAD ratio, there is increased conversion of pyruvate to lactate. So increased concentration of lactic acid is there. Then there is increased conversion of oxaloacetate to mannate. So if this is the case, TCA cycle decreases. When TCA cycle decreases, decreased ATP production is there. So overall we can say that lactic acidosis will be there, very important. Lactic acidosis. Second important feature is hypoglycemia will be there. And third is hyperuricemia is there. Now one question is there, that say if you are working in a hospital and a completely, totally drunken person comes and he is almost fainting. So common observation is that we might think the person is in hypoglycemia, so we might give him a drip of dextrose. But if a person is into alcohol, first of all, thiamine will be given intravenously, after that glucose is given. Or this is a very common observation which has been actually seen in the OPDs. So what happens, I'll just write it here. If a person comes to the hospital, right, drunken, and obviously having a faintish feeling, drunken and is fainting. Why? Because hypoglycemia, is fainting due to hypoglycemia. What is your mode of treatment? So what you will do is, the treatment would be simply thiamine is administered. Followed by glucose. Now, why thymine will be administered? Because this thymine is going to TPP. It is going to convert pyruvic acid to acetyl coenzyme A. Why? Because TPP is a component of PDH. So, immediately the brain will get energy. Okay. So, this acetyl coenzyme A will automatically combine with oxaloacetic acid. Reaction will proceed forming citric acid, or you can say it will lead to aerobic respiration. So, this one has to keep in mind कि if a person comes to the hospital drunken and is having a faintish feeling, immediately thymine is given, followed by glucose. Okay, thymine, or you can say thymine is nothing but B1. And this is a question which has been asked in the exam also, so you have to just feel, because you have to take him out from hypoglycemia, so automatically aerobic respiration, or we can say the brain will start working. The brain will start working. So, this is all about the metabolism of alcohol. And always remember, whenever we talk about alcohol metabolism, you should know what are the different type of alcohols also a person is consuming. What is the amount, percentage of alcohol? Just if we talk about beer, if we talk about wine, everywhere it is written. And what happens when a person is having, more alcohol. So, how the peroxisomes are related, how the endoplasmic reticulum is related, how cytoplasm is related, how mitochondria is related, because this is going to affect the entire thing. So, that's all about the metabolism of alcohol. I hope this video is clear to all of you. Thank you so much.